Okay, this video is about doing rigging with Blender and then importing it, exporting it to glTF and then importing it in Assimp asset importer library. So this is just going to be a proof of concept object. So first I'm going to click on the camera, press X to delete, click on the cube, press X, click on the light source, press X, so we get a clear workspace. I'm gonna first add a armature. I'm in object mode, Shift A, add armature. I'm gonna rotate it around the Y-axis by 90 degrees. And I'm gonna scale it by factor of 2. And to create a kinematic chain, I'm gonna go into edit mode. I'm gonna press E to extrude. And I'm gonna scale it to factor 2 as well. I stay in edit mode. I stay with this armature selected. I'm gonna use Shift A to add another bone, and GX, I'm gonna move it, GX, I'm gonna move the bone, Control snap to grid, I'm gonna move it to the tip of the kinematic chain. So I'm gonna rename the bones. This one's gonna be upper bone. This one's gonna be lower bone. And this one's gonna be stay inverse kinematic. Is the same name as another video, which I can recommend to watch. I'll link it in the comments below, which is about rigging airplane gear in Blender. So now I go into pose mode. I'm gonna select stay IK first by clicking on it, and then I'm gonna shift click on the lower bone, which is the end of the kinematic chain. I'm gonna go to not constraints, I'm gonna go to bone constraints, and I'm gonna add an inverse kinematic constraint. And the target is gonna be armature, and the bone is gonna be stay IK. And the chain length of the kinematic chain is 2. We have 2 bones which we want to be affected by this. And if everything is correct, the constraint should appear under the lower bone in the tree view. So now if I select in pose mode, select the stay IK and use G and then mouse to move it, you can see it'll update the upper and lower bone correctly. So go into object mode, I'm going to select the armature, then I go into object properties, I go to viewport display, I'm going to show the display the name, and I'm going to display it in front. Shift A, I'm going to add a cube, scale with S, Shift X to only scale Y and Z, and then with GX I'm gonna move it, Control snap to grid, use Control to snap to grid, and then Shift D to duplicate, GX to move along X-axis, Control click, now I'm gonna click on the cube and then shift click on the armature to select both, and then I'm going to switch to pose mode. So the cube is selected, and then I select the upper bone and I say Control P, and I set parent to bone. I go back into object mode. Now I select the other cube, shift click the armature, go again into pose mode, select the cube, shift select the upper bone, the lower bone, sorry, and then Control P, and I say set parent to bone. So now if in pose mode I move stay IK, you can see it'll move the cubes. So I go back into object mode. I'm gonna add a Shift A UV sphere, S to scale, GX to move up, Control to snap, and I put it on top of the stay IK bone. So now we want to attach the stay IK bone to the sphere. So we click on the armature in object mode. We go into pose mode. We select the stay IK bone by clicking on it. Now I go to bone constraints and I say add bone constraint child off, and I set the target to the sphere. So now if I go into object mode, if I click on the sphere and I change the position of the sphere, you can see it'll update the cube positions. So that's basically a proof of concept for rigging. In order to control the position of the whole object, I'll add another armature. This one is going to be called control. So I'm going to click on the armature and then shift click on control and then Control P. I set the parent to the bone. In the tree view you can see the sphere is on its own, it's not parented under control, so we're gonna do that as well. We're gonna click on the sphere, shift click on control and use Control P to set the parent to the bone. So now if you go on the control bone and rotate it around the y-axis, for example, you can see everything is moved correctly. If you use this object, you might want to control change the top level pose of the object programmatically. To create space in the tree for that, I'll add another armature, Shift A, armature. I call that one root. And then I'm gonna put the root under I put the control under the root. So I click and drag, and then I click Shift, I press Shift to parent. And drop it. So now it's under root. So now if you move root, it'll move everything. If you move control, control stays in place. Root stays in place. So I'm gonna animate this. I'm gonna go into the animation editor, select the control bone, go on the rotation, insert a keyframe, and then shift right arrow, go to the end of the video, set the rotation to 90 degrees Y for testing, press I to insert a keyframe, and now if I go shift left arrow and then press space, it should animate the whole object. Okay, I press space again, shift left arrow. So now I go into the nonlinear animation editor and I push down this action. So now I'm gonna select the control bone in the tree. Then I'm gonna go and bake the action for glTF. I go and bake action, only selected bones, and I bake the object transformations. Click OK. Now you can see it has baked the action. So I can press on control action, press X to delete, and I can rename this to control action. Push it down. Okay, this one need to rename again. Okay. And now if you press space, it still should work. And shift left arrow goes back to the beginning of the animation. So I'm gonna uncheck the control action. I'm gonna add another animation. I'm clicking on the sphere in object mode. I'm gonna press I to insert a location keyframe, and then I press G and shift Y to move it in the XZ plane. So I move it somewhere to another location. Oh, wait a second, escape. I need to press shift right first. And now G, shift Y. So move it to another location. And I say I for insert location keyframe. So now if I go shift left arrow and then press space, you can see it'll animate the kinematic chain now. So I'm going to select the armature and shift select the sphere. And then we're going to bake the second animation. Now you can see it has generated animations for the armature and the sphere. So I push it down, rename it to cube action, for example. Push this one down as well, give it the same name so that they will get grouped together in one animation in glTF. So if you press space, it should still work. Okay, let's press space again, shift left. So I'm gonna save this project. So I'm gonna check the control action so that all animations are activated, and then I go and export glTF. I'm gonna switch to glTF instead of GLB. I name it test glTF, and the animations should be enabled. You don't need bake all objects because we baked them manually already. Now you can export to glTF, and now we should have the animations in the glTF file. So now we go to the coding screen. And here I have a few code snippets to play around with animation data in Clojure with the asset importer library, which is part of LWJGL game library. You can do this in Java, of course, as well, but in Clojure you can do it interactively, which is a bit nicer. So I'm going to import various classes from the Assimp library, and then I'm going to load the object I just made, the glTF export. You can see the name of the scene is scene, and it has 3 meshes. We are interested in the animations, so I go to my animations section. So you can see that the scene has num animations 2, which is correct. We have 2 animations, and you can get the animation, take the pointer and create an animation object from it, and then, for example, query the name for each. And you can see we have control action and cube action. If we, for example, take the cube action, which is a more complicated one, you can check the duration, you can check the number of channels, you can, for example, get all the names of the nodes. So you can see you have sphere, armature, stay IK, lower bone, upper bone. And let's say we are interested in the upper bone. That's animation number 4. You can check it has 2 position keys, and it has 250 rotation keys and 2 scaling keys. So you can see this one is rotating around. Or if we go to the sphere, this one has 250 position keys and only 2 rotation keys. You can basically access that data then. Okay, that's basically everything. How to export from Blender and import with Assimp. Okay, thanks for watching.